I've done many seismic surveys in the past. I think this is one of the most challenging jobs I have done in my career.
Because mine is operating constantly, we had to adapt our survey, especially with the tough and noisy conditions of work.
It is a very complex experiment. Compared to surface surveys, we are limited with space, we are limited with communication.
Is it up and running?
Please copy.
Yes, over and out.
We had to face with a lot of water, with the heat, temperature.
We also how our cables can go through various locations, so it is very challenging to deploy everything.
We had to drill holes in the walls of tunnels to place our sensors.
The underground has several special conditions of work. We have dust, we have noise near the fans, we have also gases, so we cannot go inside their collector before we have a special permission from the control room. Ok, as condições mantêm-se boas então, hein?
The logistics is very complex. A lot of safety requirements, which are very needed, of course.
Safety boots on the surface can be sharp boots, no problem. We have enough time to get out of the places with this and to go to a safe place. It's not a problem at all.
We need to help people to be aware of the hazard so they can avoid it. Providing all this information about our rules and how they may behave underground.
Não, mas tens dois. Há um que está aqui à frente. Tira lá.
Guys, can we check your names, please?
Fatma.
The place where Smart Exploration is working is inside the air collector, and in this air collector we have more specific hazards, and once they are solved we can start to work safely.
One of the challenges that we have is to locate yourself and your sensors in the underground. So the crew here are surveying every receiver point that we have in the subsurface, so we will be able to put everything in one context. At the moment we are at level 590. This is about 650 meters below surface. We have instrumented 4 exploration tunnels. They vary from 600 meters long to the shortest one we have, it's about 400. We have about 500 receivers in these tunnels using different types of sensors we have.
We use the conventional geophones and as well as MEMS 3-component digital sensors.
We are testing them. They're connected to geophones, but we are testing them together with the GPS time system that we have in the underground.
This is our main recording point, and you can think of it as the control room. This is where we are recording our data. So if something fails in this portion of the survey, the data will just not come to us. I communicate the information from the recording vehicle to a person, the person communicates to the source, and at the same time I can look at my noise screen in this segment to see where the source is located and is the data and the signal coming directly.
This is source speaking. We've moved the source to position 187 and we are ready to shoot. From my van, I send the signal to the machine. It starts shaking and the signal goes into the ground. It goes to the sensors. The sensors send the signal to the record fan, and then they're collecting the data and will do some cross correlation on it, and then they will see my signal in the ground and the reaction to it.
Recording will continue, but source will operate tomorrow on the surface. So tomorrow we will be shooting from surface to the underground.
In exploration, as we are looking for blind ore bodies, we are looking for reflectors, but we only are sure of what we have below our feet after drilling. But the first step is identify targets using the seismic. And after we will decide, according to the geology, if they are really interesting, trying to find massive sulfides or not.